All right, let's get into it. Today, we're going to break down a paper that's, and I'm not exaggerating here, one of the most important papers in AI history. It came out in 2017 from some researchers at Google, and it has this perfectly simple title, Attention is All You Need. And believe me, this paper didn't just nudge AI forward, it completely spun the whole field around in a new direction.
So let's start with a really fundamental question, right? How on earth do you get a computer to understand language? I don't just mean reading the words on a page. I mean getting the context, the vibe, how all the words connect to each other. How do you do that?
Well, for a long, long time, the answer was pretty straightforward. You do it one word at a time. Seriously, the models would read the first word, then the next, then the one after that, trying to kind of hold the meaning in their head as they went along. Imagine reading a sentence by revealing one word at a time. That was basically the approach. And that right there, that's what we'll call the sequential problem. Because that whole one word at a time thing, it had a massive built-in flaw. So the models that worked this way were called recurrent neural networks, or RNNs for short. The idea was actually kind of clever. As the network looks at each word, it updates this little packet of information, like a running summary, and it passes that summary to the next word it reads. So in theory, by the time it gets to the word it should remember the cat or the dog or whatever it was from earlier, hopefully. But, and this is a huge but that the paper points out, you just couldn't get around the core problem. This process is just slow. Slow. Each step has to wait for the one before it to finish. And worse, the longer the sentence got, the more that little memory packet turned into a jumbled mess. It's like a game of telephone. By the end of a long sentence, the model completely forgot what was said at the beginning. Okay, so this really lays out the whole problem versus the dream scenario. On one side, you've got the old way, the RNNs, which is basically a traffic jam. One car has to move before the next one can. It's a bottleneck. But on the other side, that's the goal. Parallel computation. Imagine being able to see and process every single word in a sentence at the exact same time. No waiting, just boom, instant context. And this is where things get really exciting. The paper comes along and suggests something, well, radical. They didn't just want to build a faster car for that traffic jam. They wanted to rip up the whole road and build something completely new. They basically said, let's throw out that entire sequential idea. And this line from the paper's abstract, this was a bombshell for the AI world. They said they were proposing a totally new architecture called the transformer. And the key feature? It completely gets rid of that step-by-step process. No more recurrence. Instead, it would be based only on something they called attention mechanisms.
Okay, so what is this transformer? What's under the hood? How does it actually manage to look at everything all at once? Let's take a look.
From a bird's eye view, it uses a pretty standard setup called an encoder-decoder. You see this a lot in machine translation. The first part, the encoder, reads the sentence you give it, let's say in English, and chews on it until it has this really rich mathematical representation. Then, the second part, the decoder, takes that representation and uses it to write the new sentence, say in German. But the real revolution is what's happening inside those two boxes.
And that magic ingredient is called self-attention. This is the big idea. Forget going word by word. With self-attention, when the model is processing one word, it can simultaneously look at every other word in the sentence. It figures out how important each of those other words is to the one it's currently focused on. It's like it's drawing lines of connection between all the words at once, creating a complete map of the sentence's meaning in a single shot.
But they didn't stop there. The transformer takes this even further with a concept called multi-head attention. It's brilliant. Instead of having one self-attention mechanism, the paper says, let's use 8 of them in parallel. You can think of it like having 8 different experts all reading the same sentence at the same time. Maybe one expert is focused on the grammar, another is tracking the subject and object, a third is looking at pronouns, all at once. By combining their perspectives, the model gets this incredibly deep, layered understanding of the text. Now, this all sounds pretty cool in theory, right? But why does it actually work so much better? Well, the paper spells out some very clear, almost mathematical reasons why self-attention just wins.
Yeah, so what is it about looking at everything at once that's such a game changer?
Okay, this table from the paper says it all. For the old recurrent models, the number of steps it takes to connect the first word to the last word gets bigger the longer the sentence is. That's what O of N means. But look at self-attention. The path length is O of 1. That means it's constant. It takes the same amount of effort, just one single computational step, to connect any two words, whether they're right next to each other or 100 words apart.
And that right there is the secret sauce. Because the path is so short, it's always just one step, the model gets really, really good at learning what we call long-range dependencies. You know, when a sentence starts with the big fluffy chat, and then way, way later it says it chased its tail, the model can instantly connect it and its back to cat. That was a massive headache for the old models, but for the transformer, it's a piece of cake.
Of course, a beautiful theory is one thing, but what about the results? Well, the numbers they put up in this paper weren't just good, they were record-shattering.
So, how did it actually do? On a really common translation test, the transformer hit a score of 28.4. Now, I know, that probably sounds like just some random number, but you have to understand, in this field, researchers would battle for months to get a 0.1 improvement. The transformer beat the previous best model by over 2 whole points. It just smashed the old record and set a completely new state of the art.
And you know what might be even more mind-blowing than the score? The speed. To get these incredible results, the model only had to train for 3.5 days on 8 GPUs. I mean, for this kind of task, that is ridiculously fast. It was a massive clue that this new way of doing things wasn't just more accurate, it was way, way more efficient. Better results in less time. That's the dream. And this chart really drives the point home. The transformer got those better results using almost 10 times less computational power, what we measure in flops, than the previous champion. Let that sink in. It wasn't just a little more efficient, it was a completely different league of efficiency.
So when the authors got to their conclusion, they weren't just wrapping things up. They were basically laying out a roadmap for the next decade of AI. You can tell they knew they had stumbled onto something huge.
Yeah, they literally said they were excited about the future and planned to use these models for all sorts of other tasks, not just translation. And wow, were they right. That transformer architecture, it became the fundamental building block for pretty much every major AI model you've heard of since, from BERT all the way to GPT.
And it all comes back to this one powerful question that the paper implicitly asks. What becomes possible when you finally stop going step by step and you start paying attention to everything all at once?